supported by a European-funded project for development introduction. Hello and welcome, everyone. Thanks for joining this talk. Let me share my screen with you. Can everyone see my screen?
Yes.
Okay. In this talk, I'm going to take you through a story, a journey in a story type narrative. I hope I won't put you at sleep in this warm afternoon. The journey started about 15 years ago, around 2011, which I would call it the first marathon, which was about initiating a research, basic research about a new concept. And then second marathon started a few years afterward in 2018, supported by a European-funded project for developing a solution. And then the third marathon started almost at the end of it from 2022, which was about promoting the impact. And it continues up until today. So the first marathon was conceptualizing the notion of green scheduling. And for those of you who may not be familiar with the concept, scheduling is about defining the order of activities in a project with a number of objectives. It could be scheduling a project activity, set of project activities for fastest completion of a project. It could be a construction project. It could be a manufacturing project. It could be an event setup project. So many different projects are there. And scheduling is about defining the timing of activities and the sequencing of the activities in order to achieve some metrics, minimizing delays, maximizing profit, minimizing cost, etc. And I've been working on the field of scheduling almost for the past 25 years. As soon as I got my PhD, I've been working on it, and because of the different objectives involved in scheduling, majority of my work in traditional scheduling was related to multi-criteria scheduling with more than one objective. And these objectives, as I said, were mainly related to either cost or performance-oriented metrics. From about 2010, with the rise and growing attention to sustainability in operations, I spotted an opportunity to add or explicitly consider an objective taking care of energy consumption in operations. And in collaboration with a colleague, we identified an opportunity in one example, because in order to conceptualize this concept, we needed an example to work with. And we identified an opportunity in manufacturing where there was a trade-off between completion time, speed of completion of machining operations, and energy consumption of machining equipment. And we started working with this problem, and we identified some areas that these two objectives cannot go hand in hand. In other words, if you want to minimize completion time of a set of manufacturing activities, you need to consume more energy, and vice versa. If you want to minimize energy consumption, you need to prolong the completion duration of activities. Common analogy to this phenomenon that probably everybody has observed is the relationship between speed of a car and fuel consumption. You know, all cars have most fuel economic speed, which I think here is around 65, 68 miles per hour. And at that speed, car will consume the minimum amount of energy per mile. And if you want to increase the speed to get to destination faster, your fuel consumption will go up. Similar analogy we found was applicable in manufacturing operations. So we coined this new approach to scheduling, green scheduling, and we published a paper out of it in European Journal of Operational Research. I think this was the first time this term has been used in the academic literature, in which we analyzed trade-off between make span, which is the completion time of all jobs, and energy consumption. This paper was published in 2016. After that, I was looking for finding an opportunity to implement this concept. That paper was based on some hypothetical examples, although inspired by real data, but the whole concept was based on some assumptions. I was looking for an opportunity to implement this in a real application. And at that time, I got connected with the port of Felixstowe and realized that the type of work they do in optimizing container yard operations and the complexity of yard operations, and Felixstowe being the largest container port in UK, had a wealth of experience and a very focused knowledge about areas where operations can be optimized at the cost of energy consumption. So we thought that there would be an opportunity to test it in that context. A bit of background to the context. Maritime shipping, as you know, is the backbone of world trade. About 80–90% of global trade is moved by sea transport, and ports have a key role in this network. And they have environmental impact in addition to economical impact on the whole global supply chains. Out of all types of cargo, container terminals are a very big player in the maritime shipping. They carry around 60% of the cargo in the world. People put items in standard box, and this has simplified the transportation. This mode of transportation revolutionized global trade from around, I think, 1960. This mode of transportation has emerged, and it made transportation in large scale using mega ships very feasible and practical. Container ports, as a result, have started playing a key role in this domain, and they capture complexities and environmental impact because majority of the container ports are very close to urban areas. The port of Felixstowe, as I said, is the biggest container terminal in the UK with about 4 million 20-foot equivalent, or TEU, container handling capacity. TEU is the unit of cargo or container cargo, and it refers to a container with a 20 feet length. So this blue container here with a length of 20 feet is a 1 TEU container. And if it is 40 feet, it's 2 TEU. So Port of Felixstowe handles 4 million of these containers, or 2 million of these 2 TEU containers per year. And in order to appreciate the size of this operation, to put it in context, the size of operations inside the yard of Port of Felixstowe involves, on a yearly basis 21 million kilometers truck journey, which is 14 million kilometers by internal and 7 million kilometers by external trucks. Containers that are brought by external customers to the yard and then internally moved by internal trucks. So huge amount of transportation and movement are there. And you can imagine the amount of fuel consumption and potential saving. There is a metric for container terminals, movement per container, and it's a KPI that is used by terminals in order to assess and measure their performance. The ideal number of movements for a traditional container move is 2. So 1 move for taking container from external sources to the yard, and then from the yard to the vessel, or the reverse, from vessel to the yard and from yard to the external customer's truck. In some special cases for small terminals, we may have 1 move per container in which we don't have any yard waiting. So containers come directly from external trucks and are loaded to the vessel and vice versa. But these are very rare, and they are mainly for small terminals. For medium to large size terminals, 2 is the minimum. But because of the complexity of operations, we normally see around 4 to 5 move per container. And it is an area that terminals want to improve, because the less the amount of movement, containers can handle more cargo and make more profit and reduce their cost. Again, to put into context, what does 4 million TEU really mean? You may remember the blockage of the Suez Canal in March 2021 by a container vessel called Evergiven, which belonged to a company called Evergreen, with a total capacity of around 20,000 TEU. This is just 1 vessel. The chain of trucks, if you want to put the containers that are loaded in this vessel onto trucks, and then these trucks start moving from Port of Southampton in the south, it stretches all over to the north of Scotland, and the last container is still in Southampton. So this is the cargo of just 1 container vessel. And 4 million is a huge amount of containers. Well, in the Port Forward project, which was a European-funded Horizon 2020 project, started in 2018, we proposed with the Port of Felixstowe to apply the concept of green scheduling in container terminal operations. And one of the specific objectives of this project was to develop green port solutions, adopting green technologies to reduce the environmental impact of port operations and save resources. There were 13 partners from 7 different European countries in this project. And in this project, we worked, one thing happened in the meantime was Port of Felixstowe could not continue with us. When we got the funding, they had to pull out because of their internal limitations, and we replaced them with the Port of Vigo in Spain. So we continued the project with the Port of Vigo instead of Port of Felixstowe. Ports are mostly, and one of the justifications for this approach was the environmental impact of ports and the port-city relationship. Ports are mostly integrated with cities. Major ports like Port of Shanghai, Rotterdam, Vancouver, Barcelona, Genoa, London, and Los Angeles are very close or integrated with their host cities. And this is an extract from Los Angeles Times blaming Port of LA as the biggest polluter of the Los Angeles area. And this diagram to the right is an example, a snapshot from marine traffic during the COVID time. And you can see these are the queue of vessels waiting there to load and unload their cargo. And the vessels need to generate electricity for their operation. So when they are waiting and berthing, when they are waiting in the areas near, in the anchorage area, in the queue, at the ports, they keep generating emissions, and these emissions are moved to the urban areas. And because of this, ports are under severe pressure from local councils, local authorities, as well as from their customers to improve both their performance and reduce their environmental impact. So with the Port of Vigo, we started developing this tool which aimed to improve both objectives, improve performance in terms of minimizing delays and maximizing productivity of the port, and also reducing their energy consumption by means of operations planning, because there is another move in container ports by electrification using electrical equipment, which can reduce the amount of emission locally. But if the electricity that is used by the electrical equipment are not generated by the renewable sources, this emission is generated actually somewhere else. So in reality, it doesn't reduce the overall emission of the port operations if you take into account scope 2 and 3 of emission at the port. Electrification can shift emission from one location to another location if it is not generated by renewable sources, which is still very limited. So the majority of electricity for electrical equipment are still generated by means of fossil fuel and traditional conventional energy sources. So Port of Vigo, which was the case of our project, is one of the exceptional ports in Spain on the Atlantic side. Majority of the ports in Spain are in the Mediterranean side, Barcelona, Valencia, etc. But Port of Vigo is on the Atlantic side, and it has 4 terminals. And one of these terminals is their container terminal. They have a cruise terminal, a fishing terminal, and a ro-ro terminal, which is for import and export of cars. And we work with the container terminal. Container terminal operations normally includes 2 types of operations, on the sea side and on the land side. On the sea side, we have operations like berth planning, vessel scheduling, key crane scheduling, etc. And on the land side, we have storage space allocation, yard crane scheduling, yard truck scheduling, etc. And in order to identify which one of these areas are priority for the Port of Vigo, we did 2 things. We first did an extensive, comprehensive literature review in which we identified more than 10 operations planning problems that could be modeled and optimized using operations research methodologies. And after consultation with the Port of Vigo, we narrowed them down into 3 problem domains. One of the things that we did in this project was a preliminary sustainability assessment to see what are the main causes and roots of the extra emission at ports. This is the summary of this preliminary sustainability assessment based on the carbon footprints per TEU, or the unit of cargo. And as you can see here at the Port of Vigo, about 50% of the carbon footprint is related to the vessel itself. Vessels, when they are waiting at port for loading and unloading, generate about 50% of the emission. Then it comes the trucks with 31%, then yard cranes by about 10%, rich stackers or small trucks about 9%, and then key cranes only 3%. So with this in mind, and the type of problems that we identified during the literature review and after consultation with the terminal operator, we selected 3 problems in order to include in the first version of the Green Yard Scheduler regarding housekeeping and yard crane scheduling, as well as container positioning. And the rationale for these problems were to firstly minimize the vessel waiting time. The faster you process the containers, the shorter a vessel will need to wait. And then movement of yard equipments, as you noticed, cranes and trucks are among the largest contributors to the terminal emission. And these are the type of equipment are used in container terminals. We have rubber tiered gantry cranes, or RTGs, and rich stackers. These 2 equipment together, if you remember, contribute to about 20% of total emission. And then trucks, internal movement vehicles, or IMVs, and external trucks to about 30%. So these equipment together contribute to 50% of emission generated by a container terminal. The other 50% is generated by vessels, but these equipment, if they are scheduled properly, can reduce the vessel waiting time as well. So that's the rationale for this selection. So I'm now going to take you very briefly towards these three problems, just to give you an idea of what does the solution do. The housekeeping problem is to determine the sequence of container movements in a bay area in an operation called pre-marshalling to eliminate any further reshuffles to reduce the vessel waiting time. If you can see in this diagram, containers are put on top of each other like shoe boxes on top of each other in your closet. And the sequence of loading of these containers onto vessels are determined by the vessel loading plan, vessel arrival time, etc. So because of these containers are put on top of one another over time, they are not necessarily aligned with the vessel loading plan. So in order to reduce vessel waiting time, these containers need to be reshuffled and put in a proper order so there won't be need for any reshuffle when the vessel is waiting. This operation is called housekeeping, and it is normally done during the off-peak period. And the two objectives for this operation is minimizing number of container movements to make a bay area an organized bay without any blockage, with minimum number of movements, and to minimize the estimated energy consumption of the RTGs. We have loaded containers, we have empty containers, and the movement of containers based on their weight and the distance can have different implications on their energy profile. So the housekeeping module takes care of this and produces a list of container movements with, in case there are trade-offs between the number of movements and energy consumption, highlights them, and then the user can select which one they want to choose. The second module is inspection container positioning problem. Out of all containers that arrive at the port of Vigo, 20% of them are called for inspection by the inspection and customs authorities every day. And when they come back from inspection, they need to be allocated a space, a position in the yard. And this module is dedicated to this job, and the objectives are minimizing energy consumption of the internal and external trucks, and minimizing the number of future container reshuffles. The inspection gate is on one side of the yard, and when containers come back from inspection, one simple solution would be to put and stack them very close to the inspection. So you can have a very short truck journey if you put everything close to the inspection gate, but in future, the customer truck may need to take longer journey. And besides, putting containers all on top of each other can block other containers, which will increase the reshuffle in future. So by taking into account both objectives, inspection, container positioning problem, try to strike a balance between these two objectives. And the third objective, which is a master module, is called yard crane scheduling problem, which determines the allocation and schedule of the yard cranes, both RTGs and reach stackers, to the pending operational jobs. And the objectives of yard crane scheduling module is minimizing delays and minimizing total energy consumption of yard cranes. And in addition to the containers that are scheduled in the housekeeping and also in inspection container positioning module, there are a number of other operations in the system, like yard land gate in, land gate out operations, containers coming from land gate or going out to land gate, or containers going for inspection. All these jobs will need to be scheduled, and this module take care of all of these operations. We wrap this solution in the form of an add-on. Container terminals normally use a computer system for digital operation of their activities called Terminal Operating System, or TOS. And the Green Yard Scheduler works like an add-on to TOS. It pulls data, real-time data from TOS, processes them, and sends back the outcomes to TOS. And this is the relationship between the three modules: housekeeping module and inspection container. Positioning modules send their outcome to yard crane scheduling module, and yard crane scheduling module generates the schedules for implementation and send it back to terminal operating system. At the end of the project, we tested the performance of the Greenyard scheduler against the current practice at the Port of Vigo, and we observed there is significant room for improvement in terms of crane energy consumption. We observed 36% potential for reduction. In terms of truck energy consumption, 13%, and in terms of container movements, we observed 19% potential for saving. The development of the Greenyard scheduler at the end of the Port Forward project reached to TRL level 7. And just to give you an idea of the TRL terminology, technology readiness level is a stepwise classification of the readiness of a new idea for application and implementation. Normally, it has 9 tiers. TRL 1 is about basic principles observed, and TRL 9 is actual system proven in operational environments. And if you look at different technologies around yourself, you see technologies and applications in different levels. So a few years ago, electric cars were around technology readiness level of 6, 7. Now they are viable options and they are being used at TRL 9. Now we have a new wave of artificial intelligence or quantum computing, which are at different levels of TRL, but still not reached the fully commercial application level. So the journey that we took through for development of the Greenyard scheduler started by conceptualizing the idea of green scheduling. This is something that we did between 2011 and 15. And then in the Port Forward project, we applied this concept in a real application, container yard operations. And we took it between 2018 to 2020 to TRL 7. And at that stage, we tested and validated the prototype of the Greenyard scheduler, and we handed it over to the Port of Vigo in 2022. There are still 2 more TRL levels to be completed before it can be considered and used as a real-world solution or real application for wider application. And this is where the third marathon began. In order to make the research and innovation an impactful thing, we needed to work towards taking it to higher TRL levels. And this is a journey that I started after the Port Forward project completed in 2022. And it involved a range of activities, academic dissemination, a number of conference presentations, an invited review, and 3 journal papers in the pipeline. This is the invited review paper that we wrote with Navid and our other colleague, Ramin, at that time. Ramin is now at Kent, and Navid came back luckily, and he's still with us. At that time, he was part of the Port Forward project in the early stages of the project. And some public dissemination, webinar for the OR Society, and a promotional video were among the things that I did in order to promote the concept. And in parallel, in order to widespread the application, I took part in a supplementary program. Most European funded projects, when they finish, they finish. So you write the reports and show how the deliverables are delivered, and that's the end of the journey. There is a supplementary program called Horizon Booster Program. I think their name may have changed now. If some of the projects have produced some exploitable results and technologies, European Commission has a supplementary support scheme in order to help the research team to take it to the market, and we subscribed, we applied for it, and GYS alongside another product, which was a Port Authority dashboard in the Port Forward project, were selected as 2 examples of such innovations with potential for marketing, and we went through a program. It took about 6 months, and it included a series of trainings and consultancy and mentorship covering things like IP protection, patenting, copyright, trademarks, commercialization channels through spin-offs, startups, joint venture, licensing, and investment and fundraising, equity versus debt capital, and different stages of investment and the different actors in it. We have a range of investors, from angel investors that cover normally anything between 20K and 200K, the sort of Dragon's Den type of funders, if you may have noticed. And then we have seed funding between 200K and 1.5 million. Then we have expansion stage between 1.5 million and 5, and then late growth between 5 and 50 million euros. So we identified different players and different actors, and then developing value proposition in order to reach out and start negotiation with different investors at different levels. As a result of this exercise, I developed 2 value propositions for the Greenyard Scheduler for 2 potential customer groups of the tool. We observed and we realized that it has 2 types of customers. The users of the system are terminal operators, and bodies that develop solutions for them are called solution providers. And we developed value propositions for each one of them. For terminal operators, the main value of using Greenyard Scheduler is energy saving, which can translate into money saving, about 5 kilowatt hours per TEU handle, based on the experiments that we observed at the Port of Vigo per TEU, which is equivalent about €1 per TEU. So for a 4 million TEU terminal like Port of Felix, so it translates into about 4 million euros per year. It can reduce 10 to 15% greenhouse gas emissions, lowering the pressure from the ports, and decreasing non-productive moves. Increasing productivity is very sensitive for terminal operators, increasing profits by 5 to 10%, and better working conditions for the staff. These are the benefits for terminal operators. For solution providers, companies that develop systems for terminals, you may have heard companies like SAP, Oracle, that produce and develop MRP system for companies. Similar bodies exist for terminal operations and port operations. Companies like Navis, DP World, etc. Generate and develop solutions, and terminal operators normally use those solutions. So in parallel, we identified benefits for solution providers by adopting the Greenyard Scheduler, which include updating their solution by embedding innovative and value-adding features, exploiting the scientific results of an EU-funded project. It reduces the research and development, research and testing, validation cycle for them, make it a low-risk investment, and promoting their brand image. TOS providers combined with GYS, they can brand their product as Green TOS. After this, I started a more focused range of activities in the form of impact accelerations, for which EPSRC has funding. I got a funding for a project called PROGIS, a 40K project funded by EPSRC, and it is managed by Brunel University. This Impact Accelerator Awards were initially managed by the funding bodies themselves, but then from some point they awarded a lump sum to different universities, I think based on their performance. Each university received a lump sum, and universities managed on behalf of the funding council the management and administration of this. And the idea was to help support outcomes of funded research to make their ways to the market. One of the things I needed at the end of the Port Forward project was more piloting in other ports. And in the PROGIS project, which stands for Promoting the Reach and Impact of the Greenyard Scheduler, I proposed to go for this. And in this project, I benefited from the partnership from Connected Places Catapult, their Maritime and Ports Division. And the project aimed to elevate the readiness level of the GYS, ideally reaching TRL 8, and to enhance its adoption and impact in other ports via prototyping a cloud-based demo, piloting the GYS in the port market research, and engaging with stakeholders of container ports by participating in business forums or events. One of the things I realized was that academic dissemination is not enough in order to reach out to practitioners. If you want to reach out to them, you need to attend their events, and their events are separate from academic conferences, and they are normally very expensive. So using your conference budget, you cannot present in their events. After the PROGIS project, and at the end of the PROGIS project, I realized another opportunity for direct engagement with terminal operator of the Port of Vigo and their TOS provider, a company called Paseco, which is a Spanish company, and their TOS is being used in addition to the Port of Vigo by 16 other terminals in Spain. So I observed and grabbed this opportunity and got another funding for GYS pilot testing and integration to engage with stakeholders. It's a 6-month project, which is now halfway through. It started in April and continues until September 2025. And the aim of this project is to engage with representatives from the 2 customer groups of the Greenyard Scheduler, which include Termavi, which is the operator of the Vigo's container terminal, and provider of their TOS system, which is a company called Paseco. And I'm now in this journey. For the sake of time, I'm wrapping up it more quickly. In terms of the engagement with beneficiaries during the PROGIS and PROGIS Plus projects, I attended a number of business events, including London International Shipping Week, which is a very huge event, and delegates from the government, United Nations, down to the shipping companies would attend. And then Connected Places Catapult Maritime Growth Summit in 2023, and Container Terminal Automation Conference in Valencia, Terminal Operations Conference, which is one of the largest events for terminal and cargo supply chain professionals in 2024 and also this year. And using the budget for the PROGIS project, I sponsored 2 events, Green Tech for Ports and Terminals in 2024 and Smart and Digital Ports of the Future in 2024. I delivered keynotes and we had a stand for the presentation and promotion of the Greenyard Scheduler, and it opened up a massive line of communication and consultation with different players in the terminal operation, shipping companies, and solution providers. These are photos from the Green Tech for Ports and Terminals, which was held in May last year in Barcelona. And this is the stand and attendance at the Smart Digital Ports of the Future in Rotterdam, again last September, which were unique opportunities to engage with practitioners and companies, organizations. They heard a lot about the Greenyard Scheduler and opened up avenues that was otherwise not possible through merely academic dissemination. And in terms of stakeholder engagement, these are some pictures from the workshop I ran at the Port of Vigo. One of the barriers at the Port of Vigo that they mentioned for lack of adoption and implementation of the tool after the completion of the port forward project was the language barrier. Majority of their operation people are Spanish speaking, and they couldn't comprehend fully the tool that we developed and delivered in English. So in consultation and in collaboration with the Portuguese company, I organized a workshop, a training workshop for the Port of Vigo in February, and delivered a training workshop in Spanish, and also had direct consultation and communication during the recent TOC conference, terminal operation conference in Rotterdam 2 weeks ago. This photo on the right-hand side is taken at the Paseco stand. Paseco is the TOS provider for the Termavi, and this gentleman next to me is the director of Termavi, and these they are his colleagues in the yard operations team. So we had direct dialogue as part of the project for the implementation and adoption of the Green Yard Scheduler by Paseco, something that if happens, it can accelerate massively the adoption of the tool by other terminals. There are still other steps to be taken, completing piloting the GYS and its integration with Vigo's TOS negotiations with Vigo's TOS Paseco, which is ongoing, negotiation with other ports, completing the cloud demo of the Green Yard Scheduler to initiate a marketing campaign for facilitation of demonstration. We are working on a cloud version of the system for marketing purposes, which is nearly complete, and engagement with wider stakeholders via the RHYME initiative. This is another initiative at Brunel. In this initiative, I'm academic partner of a small and medium-sized enterprise called MH Tech, which is originally a Norwegian company, tech company. And with them, we have defined a proposal for development of a variant of the Green Yard Scheduler called eGYS for electrical equipment, for scheduling electrical equipment. And we are in negotiation with a number of ports for its adoption. And if it is accepted, then I will work with MH Tech as one of the adopters of the concept for different application. So the third marathon still continues, and I wonder whether there is another marathon at the end, and where is the end line? The end line is not yet clear. Final words. Based on what I've observed and experienced, the road to impact is not smooth, but the journey is exciting. If you want to take this journey, it may take you out of your comfort zone. You will need to engage with people, practitioners, users, politicians, policymakers, investors that academics are normally communicate with. It requires high level of motivation and determination. And of course, it requires more support from the university beyond the financial resource, because all these activities take time, effort, and a proper recognition need to be in place. But the result could well worth the effort. And my personal view is that if you have an idea that you think has potential for impact, go for it. If you care to make a difference and fancy the adventure. Thank you very much for your attention, and I'm happy to take any question you may have.
Oh, thank you so much. Absolutely brilliant. I have one question. In terms of your next marathon, I wonder if you have ever considered about the dry pod, because you all talk about the sea pod. How about the dry pod, land pod? Now it's become very popular.
That's an excellent question. The type of operations that container terminals have is very similar to dry ports, except that we don't have the transport from a vessel to the yard, but the rest of operations are similar. And I've been thinking about it during the project. I had a close consultation with a German company who have an operation system for dry ports. And we went ahead to some extent, but we didn't conclude with a concrete agreement. Recently, I have a request from an academic from Turkey for a postdoctoral visit to Brunel, and he works for a dry port in Turkey, and he wants to do a sabbatical visit here in the form of a postdoctoral research visit, and I suggested to work on it for the development of an AI-assisted version of Greenyard scheduler for dry ports, and he's working on it. So hopefully, if it is accepted by the funder, I will have some more room and opportunity to work on this concept. But principally, it has good potential for dry ports as well.
Other questions from others?
Okay, if there's no question, I can go. Thank you, Afshin. Very interesting, such impactful research. And I really like that this operations management and operation research, it's important that the idea, methodology does not stay on the paper. So the impact that you have is really great. You are my role model in conducting the research. I have a questions regarding the model itself. Maybe it could be a bit technical, but can you please clarify briefly that what is your objective function explicitly? How did you quantify those sustainability relevant parameters?
Okay, that's a good question. I try to answer it briefly. For the three modules, we had three different pairs of objectives. One objective was about maximizing or improving performance, minimizing delay, or minimizing number of movements. And the other objective was minimizing energy consumption. And more specifically about a sustainability objective, we captured the elements that affect energy consumption. We use some of the laws of physics that define the amount of energy that is required for movement of a load from one place to another place or from one tier to another tier. And using the technical specification of the yard equipment, we calculated the amount of energy that is required to move a container from one place at a given speed to another place, because in addition to the distance, speed of movement is also important. So by the combination of both, we calculated the energy and considered as an indicator of energy consumption.
Is this speed, for instance, same for external trucks and IMVs? So do you treat them as a same variable or parameter in your model? Because I believe there might be some differences between, for instance, IMVs and normal trucks, right?
Yes, of course. We used general characteristics of trucks. For internal movements, one set of trucks, and for external movements, another. But we assume that they are consistent. So all external trucks are the same and all internal trucks are the same. If we want to go any further than that, it can be done, but it makes the problem even more complicated. And the things that affect the energy consumption is the pattern of journey. So the acceleration time, and then the cruise time, and then deceleration time. So depending on at what speed you want to travel, it has different implications and impact on the energy consumption.
Okay, just one last question. I see that other colleagues raise their hand. In terms of objective function, what are the units in both of them? In the second one, you minimize what? Is it energy?
Energy. Yeah, energy in kilowatt hour, and we convert all energy, even if it is diesel fuel. If it's diesel operated, we convert them using the technical specifications to kilowatt hour, and then we work with that.
And the first objective, what is the unit of first objective?
It depends. For example, if it is minimizing delays, it is minute or hour, it's time. If it is number of non-productive movements, it is number. If it is number of reshuffles, it's the number. So depending on the module, we have different
For
performance
the cost,
oriented.
also you have another one, or is it cost is defined as a budget limit?
No, we don't explicitly minimize cost. We minimize only the cost of energy consumption or energy consumption, but the other metrics pertain the performance related, which are more important for the terminal operators.
Got it. Got it. Thank you very much. Thank you.
My
Afshin.
pleasure.
Yeah, June.
It can be a silly question. That's what will affect the improvement of the impact factor. So I now understand that your ideal solution, the level can be applicable to other field. So is that what you are really keen to take place in the next stage to quantum lift your impact factor? Is that to having a deal or commercialization of your solution, or that is more dissemination and adopted the idea by the government or regulators?
Well, because of the impact journey that this line of research has gone through, I think the main next step for making a real impact is adoption of the solution, adoption of the tool by a solution provider. So commercialization through either licensing or direct investment for developing a new version of the current systems that has this feature. So if we can get this solution to that level, a solution provider will adopt it and use it at any extent in their solution, then there is potential for making significant impact. Other impact journeys may have different activators and enablers. For example, some research may require change of some legislation or policies, which require negotiation and discussion with policymakers. But in this particular research, the main part is negotiating with two bodies, terminal operators who are actually doing these operations, and solution providers who develop a software system that terminal operators use. The adoption of these tools can be facilitated by external policies. For example, if there are legislations about minimizing emissions by different means, and if a port has done everything they could in terms of electrification, whatever, and they cannot do better anymore, then this tool can help them reduce their total energy consumption and gain from those benefits as well. Or in terms of financial support, I had this conversation with the representative of an international bank. They have some incentives for ports in developing countries. If they adopt green technologies, they will offer them low-rate loans. So if such negotiations can be made with these financial authorities to include this solution as one example of green technologies, then it can facilitate adoption by other ports. So I don't know if I have addressed your question.
You answered well. Thank you so much.
My pleasure.
Any other question?
Hello, Ashin. I have a question.
Hello,
Yes,
Jan. Go ahead.
Yeah. I'm also doing operation research for over 10 years, and
Yes,
I have a long-standing question regarding that. I think there's a gap between the research, open research, and the real-life application.
Okay.
So yes, in some good journals, some models or algorithms perform very well, but they may not widely applied in practice. And sometimes when we do some real-life projects, the models or algorithm we apply in some companies may not be advanced enough to publish in some good journals. So I want to hear about your comments regarding this phenomenon.
Yes, that's I think a very valid point. If you want to go for practical relevance, you may lose the opportunity to publish in top journals, and if you go for high quality research in terms of academic research, you may lose on the application. There is always a trade-off between the two. there are some technological gaps in the implementation and application of the existing tools. Some of the current systems and technologies that are used, in our case, by terminal operators, lack even the very basic level of functionality in terms of optimization. So some of the terminal operating systems work like just an information system that facilitate data exchange between the user and the yard. They don't have any decision support functionality. So if you want to implement and elevate the level of their technical advancement, you just need to implement a simple, maybe linear programming or integer programming. And if you did that, and if you manage to improve the performance of this, it might not be something that you can publish in a 3-star journal. But if that company adopts it and use it, the amount of impact or the scale of impact is so enormous that I think it can well compensate what you can get from a 3-star journal. And in REF, for example, in research assessment, if you have an evidence like this, I doubt it would be ranked anything below a 4-star impact case. And a 4-star impact case, monetary-wise, I think in the last REF, when I was in charge of REF submission, was equivalent to, I think, not sure, between 5 and 10 4-star papers. So a single impact case equated more than 5, sometimes to 10 papers. So that's the way you can justify investing time in even applying the current knowledge into practice. But there are still some open questions in terms of the academic research that are still worth implementation and further research. One example, this is something I've heard from a number of major terminal operators and their solution providers, is the issue of scalability. The optimization problems in container yards are so dynamic and so complex that the majority of the existing solutions cannot scale up when the level of yard usage exceeds a certain threshold. None of these optimization engines would work, and therefore the users switch them off because they make the system slow, and they set them aside and then go ahead with their ad hoc decision-making operations. So there is still an open question how to make these algorithms more efficient to cope with the dynamic nature of operations and to be able to work under high pressure. I think these are very active and relevant open research questions for the computational intelligence, intelligent computational communities, artificial intelligence, and operations research communities. And I haven't seen much research on that side, how to develop scalable, good enough solutions that outperform human decisions.
Thank you. Thank you.
Not sure if I completely answered your question, but happy to discuss more on it over a cup of coffee sometime.